Up till you have studied what is meant by transverse wave and what are the different terminologies in the transverse wave. Now we try to see what is meant by longitudinal wave. So in order to make you understand this longitudinal wave, let me take an example of a spring. Why? Because mostly we all know that we might have played with a spring. Whenever you hold a spring in your hand and press the spring with your two fingers where the spring has been held, then what happens? You can see that some portion of the spring or the coils of the spring means at some portion will come very close to each other, and some at the other portions it might be very far to each other. The coils which are very close to each other and some might be far to each other. So this kind of motion, where the motion of this spring happens along the direction of your operation of your hands. That's nothing else but the hands here can be considered, or the fingers of the hand can be considered here as a medium direction. So once if you are directing your particular spring in this direction, then definitely the operation or the movement of the coils of the spring will be in the same direction where you are operated. So now here, what has happened here? When you press the spring with your two fingers, some coils of the spring will come closer at some particular points, and in other points the coils of the spring might be far from each other. So this kind of wave motion is called as a longitudinal wave motion. So for that one, I'll try to consider here two ends. These two ends can be your fingers, and initially let me say my spring is like this. Okay. Now whenever I press the spring, press this spring, then we can say that at some portion the coils of the spring will be close to each other, and at some position the coils of the spring will be far from each other. So this particular motion, how does this motion of the spring is taking place? How does the motion of this coils in the spring are taking place? You are operating the spring in this direction, means you are operating the particular spring in the direction, in the same direction the coils of the spring are being operated. So the longitudinal wave is nothing else but it is a wave form or the wave motion which is being produced due to the disturbances of a particle along the direction of the medium. Whenever the particles of a medium are being operated or are being produced or moved or being transported in the same direction of the direction of a medium, we say that particular wave as a longitudinal wave. So the definition of the longitudinal wave can be it is a wave motion. It is a wave motion in which particles of the medium are traveling along the direction of a medium. What is the definition of longitudinal wave? Whenever the wave motion has taken place, then the particles of the medium will be traveling along the direction of the wave. That particular disturbance which is being caused in the particles along the direction of a medium is called as a longitudinal wave. So now, what is meant by longitudinal wave? It means that it's along the line, along its line. Means in whichever the direction a particular medium is acted, in the same particular direction of the medium, the waveform will be created or the wave motion will be generated. That particular motion which is created in the wave is called as a longitudinal wave. So now here there are two important points, which are two important terminologies which you are supposed to understand in this longitudinal wave. So I have told that the coils which has come very close to each other here, that particular portion we call it as a compression. And the area where the coils of a spring are very far, it is called as a rarefaction. compression and rarefaction. Compression is nothing else but it is a region in the wave motion where the particles are very close to each other is called as an compression. Compression is a region where the particles in the medium are very close to each other. Rarefaction is a region in the medium where the particles are far away from each other. These both are the very important terminologies which we are supposed to study in this particular concept called as longitudinal wave. So let us see now the definition of compression. It is denoted by capital C. The region in the wave motion where particles of a medium are close to each other is called compression. So the region in a wave motion where the particles are very close to each other, we call that particular region as a compression, and the rarefaction, the next term will be the region in a wave motion where the particles are far away from each other is called as a rarefaction. The next one is called rarefaction. The region in the wave motion where particles of a medium are far away from each other is called rarefaction. Rarefaction. So rarefaction is the region where the particles of the medium are very far away from each other. So another important point which we are supposed to understand regarding compression and rarefaction is that you can see that here the density of the medium is very high here. The density will be very high. Why the density is high? Why the density is high? Because whenever you press the spring, what has happened? The point where the pressure has been applied is very high. There only the particular coils are coming close to each other. If the pressure is very low, then what has happened here? The coils are very far to each other. So we can say that compression is a point or a region where the density will be very high and also the pressure will be very high, or the pressure exerted will be very high. And compression or rarefaction is a region where the density will be low. Density is nothing else but I am talking about the waves, where the density will be very low and also the pressure exerted will be very low. So we can say that here density and pressure is very high, and here in this case density and pressure is low. So in compression the density and pressure exerted will be very high, and in rarefaction the density and pressure exerted will be very low. So students, from this particular lecture we have learned about that the one kind of mechanical wave, or we have studied about the one type of the waves which is nothing else but the gravitational wave, and then we have gone to types of mechanical waves. Then in the mechanical waves we have studied about the transverse wave and the longitudinal wave. In the transverse wave we have studied how the wave is being generated and how the crest and troughs have been formed. And in the longitudinal wave we have studied that it's a wave along its line and how this wave is being generated and what are the different important points which are studied in the long-term wave. That's nothing else but compression and the rarefaction. In the rarefaction, we have studied that it's the region where the particles are very close to each other, and compression is a region where the particles are very close to each other, and rarefaction is a region where the particles are very far away from each other. And one point in the transverse wave, how does the name of transverse has come? In the transverse wave, you have seen that whenever a particular rope is been moving, the rope goes in ups and down direction until it reaches to point, and then again from a particular point it comes back. So I can say that if particular rope is moving in this direction, then let me say this is the direction of a rope initially moving. Once it strikes this particular point B, then again it travels back. So what has happened here? The transfer of energy has taken place from point A to point B. Once if it touches the point B, then again it reverses back its direction. So we can say that transverse wave is nothing else but it is a transfer plus reverse of the energy. So this is how the name transverse has come into picture. Transverse wave is nothing else but it's a transfer and reverse of the energy is called as a transverse wave. So students, now I'll wind up this class, and the next class or in the next lecture we'll study about different new concepts about wave. Thank you very much.